Imagine that you're not feeling well because you have a bacterial infection. So you take an antibiotic, it's not working. Then you take a different. Still, you won't feel better. Then you visit your doctor for the third time and you're being told there's no treatment for you. What would you do? Sadly, 1 out of every 4 bacterial infections in Canada are resistant to at least one commonly prescribed antibiotic. Did you know that antibiotic resistance is responsible for 1.3 million deaths a year globally? That is almost the size of the population in the province of Manitoba. And it will be 8 times higher by 2050. Bacteria causing infections are becoming more and more resistant to current antibiotics, making today's antibiotic ineffective tomorrow. That's why new antibiotics are urgently needed. Without understanding how bacteria develop this resistance, there's no hope for new antibiotics. So, what is this resistance to antibiotics? Antibiotics are meant to kill the bacteria, so it should go inside the cell to do the job of killing. However, bacteria are fighters. They don't let the antibiotics pass through easily. Bacteria have a strong defense system at the edge of the cell, taking the first stand against antibiotics. These are known as efflux pumps. Role of this pump is to protect the bacteria by pumping out the antibiotics. Blocking these pumps are exceptionally challenging because bacteria are so smart. They can sense when the antibiotics are around and produce many pumps. More of these pumps meaning higher the resistance. That's why non-traditional approaches are indeed needed to design new drugs. What if I tell you we have a solution? Instead of targeting the pump, we can target the regulator of the pump. This regulator is essentially a switch operated at the DNA level. It can control the number of pumps present in the cell in response to antibiotics. Flipping this switch can simply bring down the pump numbers, opening the bacteria to antibiotics. Moreover, it's a single target and highly specific. So the goal of my study is to target this switch as a therapeutic option to treat bacterial infections. So far, we have discovered 3 of the potential switches using our model bacterium. And currently, we are exploring them further to understand the function. So we can outsmart the bacteria to save you, the one on your right and one on your left. Thank you.